Good morning, teacher. Good morning, classmate. My name is Marcos Salguero. My topic is enabling next generation EU and facet array system condition. Definitions. Electric warfare systems often require wide instantaneous bandwidth across broad frequency range. 20 means process converts broad means and a standardized based interface now simplify EU systems, design tests, and deployment. Similarly integrated and single-ICE transceivers provide alternative small-size, low-power EU solutions. This webcast tells the benefits of this device. To those interested in gaining an edge in the EU industry.
Hi everyone. What we're going to talk about today are a couple of features that are valuable for some of the 5G requirements that are coming out with antennas. Now, if you haven't heard of 5G, it is coming and it will be huge. It's going to change Earth as we know it, bring world peace, angels will be singing, and all things will be possible. Now, to enable this kind of bandwidth and data rates, we're going to have to do a lot of things in the RF and microwave communities, including antennas. And so these antennas are going to have to become very highly directive to save power and in order to get things localized well. So what we're thinking of is things like phased arrays for the antennas, where we're steering the beams, multiple input, multiple output kinds of
applications. Applications in the electronic phased array antennas can be electricity stable, which means the physical antenna can be stationary. This concept can eliminate all the hedge of gimbal in a radar system. It can keep an antenna locked into a satellite. When the antenna is mounted on a moving platform, it would allow a satellite to start it being around your continent without having to deal with the slight problem associated with trying to point things in space, where every movement will require an equal and opposite mass to move in order to keep the satellite established. A phased array receiver can be flush mounted on the top of commercial airplane fuselages so that all the happy passengers can receive satellite television.
डियर फ्रेंड्स, इससे पहले मैंने यूटी स्कैन के बारे में बताया था। अभी मैं पीयूटी स्कैन के बारे में डिस्कस करने वाला हूँ। ये फेस अरे अल्ट्रासोनिक टेस्टिंग मशीन है, इसको बोलते हैं फेस अरे। फेस अरे क्यों है? क्योंकि उस यूटी मशीन में क्या आपने देखा होगा, एक केबल थी लीमो टू मिनी लीमो, और उसमें सिग्नल इसमें ट्रांसमीटर और रिसीवर एक ही केबल में हुआ करता था। सेम इसमें भी ट्रांसमीटर और रिसीवर एक ही केबल के अंदर है, लेकिन इसमें क्या है कि उसमें आपने देखा होगा 70 डिग्री का एंगल प्रोब था, 60 डिग्री का एंगल प्रोब था और 45 डिग्री का अलग प्रोब था। लेकिन इसके अंदर आप देखेंगे ये पीयूटी का प्रोब है और इसमें 64 एलिमेंट्स हैं और वो एट ए टाइम में 16 फायर करते हैं एट ए टाइम में। और इस मशीन की जो कैपेसिटी है 16 इंटू 128 है और वन टाइम में ही 16 फायर करते हैं और ये 64 एलिमेंट है। 16 इंटू 64 करेंगे तो हम इतने एलिमेंट्स एट ए टाइम फायर कर सकते हैं इसके अंदर। जिसमें अभी आप देखेंगे इसमें ये एडवांस क्यों है उससे, उसका स्क्रीन देखिए और इसका स्क्रीन देखिए। इसमें आपको 4 व्यू मिलेंगे जो हमने पहले यूटी के अंदर देखा था। डियर फ्रेंड्स, इसमें आप देखिए आपको 4 अलग अलग टाइप के स्कैन व्यू मिल रहे हैं। ये हमारा यूटी का स्कैन व्यू है जो ए स्कैन बोलते हैं इसको, जो यूटी में आपने देखा होगा। ये ए स्कैन में आपको, जैसे मैं इसको ए स्कैन पर क्लिक करता हूँ।
Pros and cons. Pros. Ultrasonic facet array systems can potentially be employed in almost any test where conventional ultrasonic field detectors have traditionally been used. Facet array can also be efficiently used to provide remaining wall thickness in corrosion survey applications. Cons. The potential disadvantage of facet array systems are somewhat higher and cost and requirement for operator training. However, these costs are frequently offered by their greater flexibility and reduction in the time required to perform a given inspection. See video.
Before we begin, we look at the array element design for the unit cell here. So we're at the infinite array here. So what we need is that we, here in the first part, we can see an antenna element. This is a cavity backpatch antenna. We see the 2 ground planes and the vias connecting them to create the cavity. We have the patch antenna here, and in an infinite array, we may use the lattice pair here. This is the periodic boundary conditions, and inside this unit cell, we may add, if we like, to a radome as well, and have it included in the analysis. Once we have this design ready, we can start doing analysis. We can use, for example, design of experiment to obtain response surfaces, to optimize on that response surface. We can use that to do tolerance analysis, and to look at the sensitivities of which variables should be in a full optimization scheme, for example. This is a really good way to figure this out. And we can also look at the array factor, right? So, for example, if we have this 8x8 array factor, we could see at least what to expect. Okay, what is the gain? What is to expect? So some expectation. So we could also look, for skein blindness, for example. Next picture below shows the active S parameter. This active S parameters is for different beam steering angles. We can see how the active parameters are changing for different beam steering angles. And forgot to say, the picture above here is that we are seeing the azimuth cut for different beam steering angles again. So another approach what we could have here is that if we would have designed this antenna without the radome, could use the Floquet port, the Floquet technique to do an investigation of initial radome material selection. What I mean is that basically we could put a Floquet port in the bottom and the top, so incidence and output, and we can put our radome structure in between here, we look at the reflection coefficients versus angle of incidence. This is the reflection coefficients which we like to minimize in such a way so that when you put your radome on top, that it's almost invisible to that ray itself.
Conclusions. Conclusion: the benefits of phased array technology over conventional UT come from its ability to use multiple elements to steer, focus, and scan beams with a single transducer assembly. Beam steering, commonly referred to sectorial scanning, can be used for mapping components at proprietary angles. Thank you.